Now we're going to start talking about deployment. So deployment is what an interesting problem in the continual deployment world. So the situation is that your application is executing. You have multiple independent deployment units, services. Some of these deployment units may have multiple instances and they're all serving requests. Now you have a new version of one of these. The code has been committed. It's worked its way through the deployment pipeline. It's now sitting on the staging server. And so an image of the new version is on the staging server or in some container repository. So what happens then? So if we do this visually, then we're going to replace version A of the red one with version B of the red one. And so the constraint is that you want to move from the current state where you have n instances of version A to a new state where you have n instances of version B. And any development team can deploy their service at any time. For example, you could deploy a new version of the red service before or after new versions of the blue and green service, which means that if the new version of the red service is deployed first, then the blue version doesn't know about it, so they wouldn't use the features. But if the new version of the blue service is deployed first, it may assume that there are services in the red version that don't exist yet because it has yet to be updated. The other thing to keep in mind is that it takes time to, and you get around all this with architecture. It takes time to replace one instance of version A, so these are not instantaneous. And you have to maintain service, right? Your clients are busily, making requests, and they have to be served. So there are two basic all or nothing strategies. One is red black or blue green or orange purple, or pick two colors. And this says that I have n instances running version A, and I allocate and provision an additional n instances which have version B. And then I switch to version B and release the instances with version A. That's one all or nothing strategy. A second all or nothing strategy is rolling upgrade, where I allocate one instance, provision it with version B, release one version A instance, and I repeat this. There are also partial strategies, which we'll talk about later. So the trade-offs are that if you're using the red-black version, a strategy, then at any point in time from the client's perspective, there's only one version available. But it requires that you have an additional n instances. So you have to allocate the n instances, so you actually have two n instances. And if you're upgrading frequently, then this can get complicated and expensive. But in any case, there's additional cost associated with the n instances. A rolling upgrade gives you logical problems, which we'll talk about. For example, you may have version A and version B of the red service both executing simultaneously. But it only requires n plus 1 instances. You only need one extra instance if you replace them one at a time. You could group them, replace them 10 at a time, then you need 10 extra instances, but at least that is bounded in terms of how many instances you replace at a time. And rolling upgrades widely used. It used to be the standard in the old days when these were actual physical machines. And so then you had to have your data center had to have twice as many machines as it needed in order to provide for a red-black style upgrade. With virtual machines and cloud providers, that's not as expensive, but rolling upgrades still widely used. Okay, so if you're doing rolling upgrade, what problems you have to deal with? Well, regardless of whether you're doing rolling upgrade or red-black, you have to have horizontal consistency. So you're going to have, with rolling upgrade, you'll have multiple versions of a single service executing simultaneously, some of which may have version A and others version B. That's only a problem with the rolling upgrade. Vertical consistency is a problem with either style. You have different services in a request chain may or may not have been updated. And data consistency is a problem, again, with either style. So with red and black, maintaining horizontal consistency is relatively straightforward. You would allocate two separate sets. You would change your DNS server so that it points to the load balancer for the new set. And that would have the new requests go to version B. There are still requests being served by version A, so you have to drain them before you can delete them. But that's relatively straightforward. The horizontal consistency problem with rolling upgrade is much more complicated. So a client, the blue service, may access a new version of the red service and get a response. It then sends a second request to the red service, and it finds one that doesn't know what, it finds an old version which doesn't know what this response is because it's not something that is in its code base yet. And that's an error. So the key idea about maintaining horizontal consistency with the rolling upgrade is that you differentiate between installing a new version, putting the new version in a virtual machine and getting it ready to go, and activating a new version. And this involves feature toggles. So the sequence is you would develop version B with your new code under the control of feature toggles. You would install each instance of version B with the new code toggled off. When all the instances of version A have been replaced with instances of version B, you would activate the new code through toggling the feature. So first, do you remember feature toggles? We talked about that in the development environment. And the second one is how do I activate all the relevant instances at once? So a feature toggle puts new code inside of an if statement. And we saw it in the development environment to allow developers to check in uncompleted code, which is toggled off. And again, as I said, removing feature toggles when a new feature has been committed is important because it clutters the code and it could lead to errors. So given that we're going to have all these feature toggles around, there's a new piece of software, a new manager called a feature toggle manager. And it maintains a catalog of feature toggles, whether they're on or off, and who's interested in them. And so it's used to activate and deactivate the feature. When you remove the toggle, this feature toggle manager will place, or when you say that this toggle is ready to be removed, the feature toggle manager will place something on the backlog of the development team that says remove this feature toggle. So you activate it through the feature toggle manager, and it wants to change the value. And so there are two styles, is kind of normal. You can push, so you broadcast a new value, or you can pull, which means that each instance has to query to get the latest value. So the querying, the pull can be done synchronously through the instance. The push is inherently asynchronous, and the instance has to listen for it. And there are coordination mechanisms. So something like Zookeeper or Console could be used either way. Zookeeper has an alert feature, so if the thing is changed, then it would alert all of its clients that a feature toggle has changed. So to summarize, there are two basic deployment strategies, red, black, and rolling upgrade. These are for all or nothing strategies. And maintaining horizontal consistency during rolling upgrade is done by differentiating between installing and activating. And you use feature toggles to do the activation, and that generates a requirement for a feature toggle manager. And then you would use a coordination manager to make sure that the activation is all done at the same time.